Dear participants, good morning to all of you. I hope you are doing well and in good health. I am Ganesh, Executive CSR and at IWMA, and I will be the host for today's session. On behalf of our IWMA office bearers, executive members, senior manager, and speaker, I extend a warm welcome to all for this 73rd webinar on the topic Achieving Sustainability and Circularity through Revolutionary Technologies. Due to some unavoidable circumstances, our chairman couldn't able to join today's meeting, but he conveyed his wishes to all of you. Now, we will directly move into our today's technical session. I am pleased to introduce our distinguished speaker for this webinar. Ms.Janshi is a sustainability champion with 15 years in water and wastewater treatment. She drives innovative circular economy technologies and continuously explores new advancements to scale global impact. And also joining as well, Mr. Vignesh brings hands-on experience from the renewable energy sector into specializing in sales and client relations. Passionate about sustainability and water stewardship, he actively embeds circular economy principles into technical and organization initiatives. Now, I welcome Mr. Vignesh to take over the session.
All right, thank you, Mr. Ganesh. So, good morning, everyone. So, just give me a second. I just share the screen. So, I hope the screen is visible. Can you hear me as well?
Yeah, visible, yeah, visible.
Okay. So we'll just directly dive into the presentation. So, hello all. Good morning. Thank you for joining this session, and I would like to express my sincere gratitude to IWMA for hosting this webinar and giving us an opportunity to present our technologies in front of you all. And I'll make sure this session will definitely be engaging for you guys. So today we'll be talking about few transformative technologies which are shaping the water industry around the world. And as you know, the topic that we are going to talk about is achieving sustainability and circularity through revolutionary technologies, which reflects as a modern initiative done in the industrial sector and around the world, moving towards combining sustainability and operational excellence. So we'll be broadly discussing about the real challenges and that are there, and how we can implement it in our process to make it much more efficient, tracking it and validating it using quantifiable metrics. And going on to the next slide, if you see now, as you know, we are part of the Murugappa group. So this slide will, give you an understanding about our strong foundation that we have. This Murugappa group is been there for more than a century, and where they have dwelled into 29 plus businesses, and there are 100 plus manufacturing units across India, and they have employed close to 94,000 plus employees. And this is not just a company, but it's a knowledge ecosystem where everyone works together towards one goal. And this ecosystem is something very much important, because water technology today is not only a single focus but an interdisciplinary field where combining technical chemical science, electrochemistry, automation, digital intelligence, everything put together is what water technology or water industry is about. So going on to the next slide again. So here, if you see, these are some of the group companies that are there. where we'll be able to see they are diverse in agriculture, manufacturing, chemicals, electronics, energy, and different industries. So we have a very strong foundation across different sectors, giving us a first-hand insight into the water problems that are there as well. Also, we'll be able to understand the industrial problems, not only conceptual lab solutions. So next, so talking about Murugappa Water is a uh, four uh, 4 decade old company, and we have experience in different industries as well. We have been traveling and understanding and been changing the water industry for really long time. Our commitment to serving society and empowering industries has always been the foundational of our growth. This timeline actually showcases our focus, where we have shifted from conventional wastewater treatment towards high value recovery of resources and technologies as well. So, our strong themes such as sustainability, automation, membrane science, and electrochemical solutions are the forefront over here. So, right now, we'll be diving directly into the technologies. So, the first technology that I would like to present for you is ElectraMet. So, ElectraMet is a electrochemical technology where which can help recover precious metals such as copper, silver. It can also help in removal of manganese as well. So the reason for this technology is, see, the global value of precious metals and base metal continues to increase, drive largely by constrained
Excuse me,
supply
sir.
and growing demand. Yes.
Sir, slides is not moving.
Slides are not moving, is it?
Yeah, yeah.
Is it moving now?
Yeah, it's now changing, sir. Sir, also
Okay.
you can use the full screen, sir. It will be more visible to the audience.
Is it full screen now?
Not yet, sir.
What about now?
No. Just you continue, sir. No issues. You continue.
One second, let me just reshare it. Now is it visible?
Yes, sir. You can just continue, sir. No issues. It's not doing. It's not in the full screen.
One second.
Yes, sir. Yes, sir. Now it's in full screen, sir.
Yes.
Okay. Okay, sure. So yeah, sorry for the interruption. So let me just continue from this slide. So as I was talking about ElectraMet, and I was talking about the precious metals and the base metals that are there. So we all know that the value of these metals are rising quite high, and as we all know, the reason for that is the global supply chain and the growing demand in industries. For example, if you talk about copper, the electronic industry, the semiconductor industry, the electrical electronics industry, all these industries use copper widely. So the increasing demand for copper is also increasing. So recovery of metal is very much an important thing. So let's take a closer look on how we are going to do this. If this electromet, this one is an innovative technology where it uses electrochemical absorption and recovery process. So this technology selectively captures, dissolved metals without any chemicals. So the benefit over here is when we talk about it, so we get close to 99.9% of pure copper from it. So there is no chemical sludge that's there, that comes out of this technology, and it's environmentally safe to discharge as well. So there is scope 3 reduction in emission. This is a fully automated system, and the last point is that it can also be monitored remotely. So these are the important points with respect to electromet that is there. So the next slide, if you see this is the current technologies that the industries use for recovery or for discharge compliance as well. So if you could see over here, so I've here, if you can see, there is ppm mentioned over here from 0.01 to 100,000 ppm is mentioned over here, and below are the technologies that are used for the recovery. Ion exchange is used, chemical coagulation is used, solvent extraction, electrowinning. So if you could see here over here, for different levels of ppm, different technology is used. Not a single technology can provide a solution for all the different ppms that are there. So there is a lot of process gaps, high downtime, chemical dependency is there, inconsistency of compliance, higher operational cost is also there. Sludge generation and disposable is also a very big, issue over here. Manpower, monitoring of system over here is very difficult. So combining all these problems that are there, we'll understand that this is not a very easy process to work with. But Electramet gives you that solution. Electramet, if you could see, it would work from 0.01 ppm till 100,000 ppm. We have wide range of technologies that for different concentration as well. If you're looking for, if you have 100 ppm copper in your solution, and if you like to remove it to less than 1, we have fine removal over here. And if you're looking for, if there is 10,000 ppm of copper that is present and you would like to bring it down to 0.1 or 1, we have solutions for that as well. The bulk recovery works with that. So there are solutions with us, wide range of solutions at just one stop for you. So another strong feature is the oxidant destruction, crucial in mainly in semiconductor industries, but it can also be done in other industries as well. It allows acid reuse, reducing chemical purchase and disposal. That we'll be talking about it in the next slide. So this is the Electramet's gamma system, where we could see the abatement of hydrogen peroxide, ozone, chlorine, and chloramines is done. Where piranha acid, which is commonly used in semiconducting fabs and solar manufacturing processes as well. So this challenge is peroxide decomposition. It is safety hazard and disposable challenge faced in all over the industries. So this gamma system definitely reduces, it abates the peroxide that's present in the acid, and we can reuse the acid that is already present for other purposes as well. So this actually reduces the hazardous waste. Then we can use the fresh acid for consumption. Environment impact is very much less, and the operational cost is also very much less. And if you see, combining all this part, we'll be able to understand that this is the actual circular economy that's in action. Going towards the next slide, we will be able to see the it is ultra CMM ceramic membranes. This is a conventional polymeric membrane that can work in high temperature, high acid, and abrasive conditions. So when it comes to recycling, reusing, and separation of industrial wastewaters, which are very challenging, this works wonders, and it can set a benchmark. Built with robust ceramic, it delivers superior performance as well, and chemical resistance, and also operational reliability across diverse industries. So it can remove TSS up to 99%. This pH handling can either be very highly acidic as well as basic as well. This is ideal for CMP waste. So resistance to high TDS acids and bases, as I already mentioned. So they actually deliver stable flux and they require very minimal maintenance. So this is very much critical for many industries that are there around where it is they actually have very high temperature effluents or very high acidic or basic effluents that are there where they are facing problems to treat it. So this would be a very great solution for them to use. Also, this life of this membrane can also go more than 10 plus years, but it totally depends on the usage. So now going towards the next slide, Janshi ma'am will be taking forward.
Thanks, Vignesh, for letting the team know about electromet and ultrasimum. So just to bench up, electromet is where you can recover metals that are dissolved and currently unrecoverable, and they are losing metals. Sometimes unga water la vandu pathina, by the virtue of process, there will be some metals, but it is not related to the process to recover them. It is usually sent to your wastewater treatment plant or your effluent treatment plant. It will become a place of heavy metal removal. Probably they'll be using lime mari or a alkaline medium. We'll remove them. It is moreover heavy metals are removed, not recovered as metal hydroxide sludge, which is also composite. There is no value. So circular economy in pathina, you should actually generate a value. The word economy is there, right? You are circulating it, but there should be a value generation from whatever we do. So with electromet, you can generate a value when you recover copper, and the specific thing is that you, from the mixture of metal salts or from a mixture of coexisting metals, specifically copper can be removed at 99.99%. So that is the value delivery. So close to the virgin copper, which is trading at around, the LMI is around today 9,800 USD per ton. So that is somewhere around 980 kgs, yes. 980 rupees per kg. So closer to the virgin metal, you can yield the economy. So place where there is no scope. So everybody knows, like, when there is an industry, wastewater system is known as a kind of an a capital investment, but that does not yield anything back to the industry. But with circularity getting introduced in all your feasible waste streams, I might not say we can recover everything. When there is an economic value, when there is a secondary market for it, yes, we request you to think about when you frame the system or operate the system. So coming back to the other technologies, I would like to present on the high recovery system from Rotec. Rotec is our partner for this flow reversal reverse osmosis. So I think most of the plants that use water in any of their processes earlier, we used to say sustainability was just not polluting water. So later it became that we should not let down wastewater, we should treat the wastewater. Then sustainability became that we should recover water from the wastewater. That is when all your ultrafiltration system, reverse osmosis systems எல்லாம் வந்து நம்மளுடைய ஆர்ஓ பிளான்ஸ் எல்லாம் வந்து வர ஆரம்பிச்சிது. அதுக்கு முன்னாடி பாத்தீங்கன்னா வந்து ஓகே, நம்ம தண்ணி யூஸ் பண்றோம், we should not pollute that. அதாவது நம்ம அதை வந்து மாசுபடுத்தக்கூடாது, அது வரைக்கும் நல்ல தண்ணி கம்மியா யூஸ் பண்ணிக்கலாம் அப்படின்ற கான்செப்ட்ல தான் இருந்தது. லேட்டர் when we saw that கொஞ்சம் கொஞ்சமா உங்களோட ரா வாட்டர் கன்சம்ஷன்ஸ் வந்து உங்களோட போர்வெல் வந்து கம்மியாகும். So there will not be any there'll be restrictions from the governing bodies that இதுக்கு மேல you can't withdraw from borewell. Then industries thought, why don't we see wastewater? Wastewater வந்து ஒரு water resource தான். So it is usually 99.5% water and only 0.5% solids. So if you look at the definition, it is 99.5% water. Rest of the contaminants only 0.5%. So we just want to go and recover water. That is when reverse osmosis came. அதாவது RO systems போட ஆரம்பிச்சாங்க wastewater side. So what happens for the RO systems? So RO systems were designed with certain recoveries. அதாவது வந்து how much ever எவ்வளவு தண்ணி கொடுத்தா நமக்கு எவ்வளவு சுத்தமான தண்ணி வெளியே வரும் அப்படின்றது தான் ரிகவரி. ஸோ அந்த ரிகவரிஸை வந்து டிசைன் பண்ணும்போது they take into consideration, they analyze எல்லா வாட்டருக்குமே you cannot have higher recoveries because waterல வந்து there are different level of contaminants. Different salts are dissolved. So starting from your scale formings around the calcium, magnesium, your sodium, your sulfates, your phosphates. So on the salts, the water they get the contaminated water or the used water, spent water will have all these salts, organic and inorganic salts dissolved. That is how your TDS goes high. நீங்க வாட்டர் ஃப்ரெஷ் வாட்டர் உங்களுடைய சிஸ்டம்குள்ள எடுக்கும்போது கம்மியான கண்டக்டிவிட்டியில தான் எடுத்திருப்பீங்க. But after it goes into your industry and when it comes back, it picks up, water is universal solvent layer, it picks up most of your contaminants as dissolved solids. And when it comes to your effluent treatment plant, உங்களோட conductivity and TDS it will be way high. And the recovery of the RO, or RO system or recovery pathina, it depends entirely on this composition of this TDS. So whenever you have hardness forming salts, நம்ம முன்னாடி படிச்சிருப்போம், the calcium, magnesium அதிகமா இருக்கும்போது scaling அதிகமாகும். நம்மளோட நார்மல் பைப்ஸ்லயே பாத்தீங்கன்னா எங்கெல்லாம் ஹார்ட்னஸ் அதிகமா இருக்கும் அங்கெல்லாம் பாத்தீங்கன்னா டொமஸ்டிக் அப்ளிகேஷன்லயே யூ கேன் see there are a lot of scales that form because they are bound ஒரு particular saturation concentration க்கு மேல they will not be dissolved in the water, they will start precipitating. So that precipitation is called scaling. So reverse osmosis systemலயும் what happens is there is a membrane, that is the RO membrane, ஒரு specific gradientல it keeps pushing by the principle called reverse osmosis, it keeps pushing good water to the other side of the membrane, and one side of the membrane la pathina inda uppalla thangidum. So we call it saturation. Or saturation limit ku mela pochuna the concentration over salt kume or saturation concentration irukum, and the salt dissolved condition la irundhu ungaloda precipitate condition, that is scale forming panna arambichirom. That is when your recoveries of ROs will come down as intended. என்ன நடக்கும், நம்ம டிசைன் பண்ணும்போது 75% டிசைன் பண்ணிருப்போம், 2 வருஷம் கழிச்சு பாத்தீங்கன்னா அந்த டிசைன் 75% ஓட்டி இருக்க முடியாது. So it will drop down, 70% ஆயிருக்கும், நடுவுல கிளீனிங் எடுத்திருப்போம். So after a particular time it drops down to say 65-70%. So அதே energy but less throughput, அதாவது less good water. அப்பதான் we thought of why don't we address this challenge. That is when we got engaged with Rotec for the concept of flow reversal reverse osmosis. Flow reversal reverse osmosis enna pannu, what it does is ungaloda RO systems, ungaloda industrial RO systems pathina, it is a unidirectional flow. Adhaadu first membrane thanni pogum, அதோடைய ரிஜெக்ட் சொல்லுவோம், பிரைன்ல ரிஜெக்ட் சொல்லுவோம், அது உங்களோட செகண்ட் சிஸ்டம், செகண்ட் ஸ்டேஜ்ல செகண்ட் அரேக்கு போகும். அதே மாதிரி செகண்ட் ஸ்டேஜ் உடைய rejects will go to the third stage or the third array system. That means the third set of membranes, the last membranes of your system, will be filtering out effectively கிட்டத்தட்ட ஒரு higher concentration. அப்ப 75% னா 4 மடங்கு அதிகமா இருக்கிற உப்பு தண்ணியை தான் the last stage of membranes will be concentrating. அப்ப என்ன ஆகும்னா over a period of time the last membranes, உங்களோட RO systems இருக்கிற last membraneல scale deposits அதிகமாக ஆரம்பிக்கும். So that is when recovery will drop. ஆபரேஷன்ஸ்ல இருக்கிறவங்களுக்கு கேட்டீங்கன்னா தெரியும், ஃபைனல் மெம்பரேன் உங்களுடைய வாட்டர்ல அதிகமா சிலிக்கா, ஹார்ட்னஸ் இந்த மாதிரி கண்டிஷன் ஸ்கேலன்ஸ் இருந்துச்சுன்னா உங்களுடைய லாஸ்ட் மெம்பரேன்ஸ் சீக்கிரமா சோக் ஆக ஆரம்பிச்சிடும். They will not deliver what is to be delivered. அதாவது அவங்களோட எஃபெக்டிவ் டிசைனுக்கு the membranes will not deliver. So people will then go for CIP, continual CIP will go. CIP அதிகம் பண்ணும்போது what happens, your RO pore sizes will increase and you get salt passage. உங்களோட TDS அதிகமாக ஆரம்பிக்கும். So membrane போயிடுச்சு, will replace the membranes அப்படின்ற ஒரு கட்டத்துக்கு வந்துருவாங்க. Without going to that extent, FRRO, அதாவது flow reversal reverse osmosis, will help us to have a sustained high recovery. So இப்ப 90% recoveryக்கு நீங்க டிசைன் பண்ணீங்கன்னா over the period of 3 years அத 90% sustain பண்ணி கொடுக்கிறதுக்கு FRRO will help. So what it does, FRRO என்ன பண்ணுது? So இந்த வீடியோ பிளே ஆகுதான்னு பாக்குறேன். Then why you want this video? So let me explain. In the idea we'll explain what happens. So this is an RO pressure tube. If people who wanted to understand, a pressure tube is an FRP casing or strong long tube, almost 6 to 7 meters length irukum. Your RO membranes are loaded inside this pressure tube one by one. So in the sides of the pressure tube, you have something called connecting ports where your water enters from one side, and in the center orange tube water clean agi permeate it will come out, and the concentrate will be in the same side of the feed but it will come out as the reject. So in the reject will get connected to the next tube. ஸோ இப்படிதான் வந்து மல்டிபிள் டியூப்ஸ் கனெக்ட் ஆகி பர்மியேட்ஸ் வந்து கலெக்ட் ஆக ஆரம்பிக்கும். ஓவர் த பீரியட் ஆஃப் டைம் பாத்தீங்கன்னா இந்த ஃபீட் வாட்டர்ல இது வந்து ஒரு எலக்ட்ரான் மைக்ரோஸ்கோப் இமேஜ். ஃபீட் வாட்டர் சைட்ல பாத்தீங்கன்னா ஸ்கேலன்ஸ் எதுவுமே இருக்காது. ஆனா இந்த சேச்சுரேட்டட் சைட் பிரெயின் சைட்ல பாத்தீங்கன்னா ஒரு ஒரு குறிப்பிட்ட டைமுக்கு அப்புறம் ஒரு ஒரு 1 மந்தோ அந்த ஸ்கேலன்ட்டோட கான்சென்ட்ரேஷனை பொறுத்து யூ வில் ஸ்டார்ட் சி சைன்ஸ் ஆஃப் ஸ்கேலிங். ஸோ வாட் வில் FRRO do? It will change the direction of the flow. So it is specifically designed, completely automated. நம்ம போய் இந்த டிசைனை சேஞ்ச் பண்ணணும் இல்ல. எல்லா போர்ட்ஸ்க்குமே we have given auto valves and we have calculated something called induction time. Induction timeன்றது என்னன்னா உங்களுடைய வாட்டர்ல இருக்கிற ஸ்கேலன்ஸ் எல்லாத்தையுமே வந்து அனாலிசிஸ் we'll ask before designing, we ask the analysis of your water. உங்களுடைய anions எவ்வளவு இருக்கு, cations எவ்வளவு இருக்கு, இந்த வாட்டர் இவ்வளவு தூரம் வந்து if we design it at a high recovery, எந்த டைம்ல வந்து what is the probability, எந்த ஸ்கேலிங் வந்து ஒரு கால்சியம் இருக்கு, ஓகே கால்சியம் கேட்டையான் இருக்கு, சல்ஃபேட் ஆனியான் இருக்கு, ஓகே அது அதிகமா இருக்கும்போது மேபி இந்த ரிகவரியில ஓட்டினீங்கன்னா கால்சியம் சல்ஃபேட் அப்படின்ற ஸ்கேல் வந்து ஃபார்ம் ஆகும் அப்படின்றத we understand and we go back and design a system before the calcium sulfate scaling is formed in the So we'll have this calcium sulfate scaling happening in the in this area. So in the area la calcium sulfate scaling இருக்கும். Pointer. So the flow gets reversed. The direction of flow gets reversed. The feed, which was originally going from, say, if you say this is port A and this is port B and this is port C, direction of flow was the feed was flowing through port A, it was going through the permeate tube and the permeate was collected by port C and the brine was collected, or the concentrate reject solvo, the concentrate is collected in port C. So what happens when you reverse the flow? The feed starts flowing from port C. Permeate direction is the same, but the feed and the reject directions are changed. So what happens when you change this? Already when you have saturation here, already it was saturated, oversaturated. And when you change it, the incoming feed actually dilutes this area. It makes it unsaturated and pushes towards the other end. So what happens every time there is going to be a circumstance or there is a situation that the scale is getting formed. Before the scale is getting formed, this flow reversal happens and this continues, eventually leading to all your scale formants remaining in the water itself. They don't adhere to the, or they don't stick to the membrane surface. Only when your scale gets stuck to the membrane surface, the over deposits of the scale happens and your membrane chokes. So if you don't allow the scales to stick onto the membrane surface, you keep them in the circulation, so your recovery can be sustained. So this is about Rotec. Next, we will be moving about to another membrane technology called superfiltration.
Hello, sure. Sure.
So hope my screen is visible. Superfiltration is from our partner called Zwitterco, again from they are from US. So superfiltration is a set of membranes which we call they are immune to irreversible fouling. So first நம்ம பார்த்த இதுக்கு முன்னாடி பார்த்த technology was Rotec. Rotec can help us mitigate scaling, whereas superfiltration are membranes which are in the spectrum which is lesser than your ultrafiltration, tighter than your ultrafiltration membranes. That ultrafiltration these membranes are even more finer but slightly looser than your nanofiltration. That means it is not intended. Superfiltration is not intended to remove high molecular weight inorganics, but it can help us remove high molecular weight organics. So what are the high molecular weight organics that superfiltration can remove is all your fats, oil, grease, that is there, your lubricants, dissolved organics, that sometimes it could be your organics like humic acid, any foulants that are organic in nature can be easily removed with superfiltration. Usually in industry, what happens, this stream, why the superfiltration has come to circularity of water is, usually in industry, whenever there is an oil-rich stream, they try to avoid getting water or avoid recovering water from that oil-rich stream because we don't have a very robust technology that can effectively separate the final oils. So at least you'll have, even after your DAF biological system, there is still a little oil that is left. So polymeric membranes, like your RO membranes, if you send in oil, they will immediately get fouled and they can't perform. So people cautiously avoid streams. So what happens when you avoid those streams? The water that is already there in those streams. So it is not only oil, so that the stream will also have water. The water that has been there in the stream is also not available for recovery, not available for your circularity. So with superfiltration, we can address decentrally. That means we can segregate those streams, address it with superfiltration, remove oil and make BDL. That means below delectable limit of oil, and then combine it with RO. So superfiltration effectively becomes a pre-treatment for your reverse osmosis systems. So these are certain industries, like directly they can support your dairy industry. That is because of organics, dairy, food and beverages. In electronics segment, we have seen that it is supplementing ultrasemum in final removal of waters that are contaminated or contaminated with spent coolant, machine cutting coolants that get final washes that come from the coolants, and even direct spent coolants which are rich in highly stable emulsions are being cracked with ultrasemum and finally being polished with superfiltration before it enters your mainstream ETP. So nowhere you can see a coolant that can be totally treated and even water getting recovered through RO from a coolant. That is possible because of a combination of ultrasemum, which can again reject oil, and for the final polishing with superfiltration from Zwitterco, that helps us to give an oil-free feed water to RO system. So we are adding whatever was initially not considered in the water balance of the plant. Initially that 50 KLD or 25 KLD of coolants will not get considered in the water balance. Now we circulate back that water also effectively into the main water management. So for superfiltration, we do have test bench. We call them bench pilots as well as the field pilots. If you have any stream that has got a contamination of oil, or it is entirely, like I said, coolants from your machining area, where you feel that you are unable to dispose them because it is high in volume and it is highly contaminated in oil that you cannot mix it with your regular effluents. So usually we'll have to howl it. We'll send it to the third party, and that is again a howling cost is there. Or we'll have to give it because of the high wet condition. Incinerators might not work for that oils also. So for those streams, we can test at your place. We can get this pilot directly to your place. We can run a test with the effluent sample, and you can see the efficiency and scale it up. So most of the technologies that we speak today are having the feasibility check pilots. They are having design level POC pilots that can come to your place for conducting of the test. So you can put in all the possible combinations of your effluents. That is how we do recommend the technologies. It is not like we just start promoting marketing once you send us an inquiry. We do come place we just come there, understand your stake points, and then do the piloting, and then recommend, okay, this is what is the efficiency, this is how it has to be designed. So to complement all these water technologies, we have a water energizing unit called Jiva. So what does Jiva do is, it actually does not add any supplements, or it does not filter out, or it does not treat water. It rearranges water's potential of hydration. So it helps in providing a better wettability to your water. That means better penetration power to the water. So Jiva is usually a point of use device. Finally, after all your treatment, Jiva can be just like your the final facet that delivers your water to the process. Jiva can become the part of that final point of entry that is going to enhance the solubility of water. So because of the better hydration, it solubilizes more, it spreads more. So you can leverage the benefit. If at all you need a water that has got a better, that solubilizes more and it needs a better wettability, that is where we can employ at the outlet of all of these devices, that is purification, treatment, TDS removal, everything is done. You're just going to use the water to your process. That is where Jiva can come handy. So some of the applications are, for the heat transfer, your chilling applications, your cleaning applications, using Jiva water as the source for your preparation of cleaning chemicals, surface cleaning chemicals. So those areas is where you can complement the usual treated water with Jiva, and it will help you to achieve, in terms of heat transfer, we have seen it is improving the heat transfer efficiency. And it is the water is getting heated with a lesser time. And in terms of cleansing property, because it has got a better wettability, you can have it, it covers more surface than your regular water. So on top of all these technologies, so these are all hardware technology, means we have to supply, we have to deliver them as systems. But there is one service that comes as an umbrella to all the operations that are happening in the plant. So that is the operation management and operation intelligence from Pani. So what does Pani offer to a shop floor of a water treatment system, or a shop floor of a in process industry as well? So it can get extended to your process floor also. It is not only the water plant, it can get extended to your process floor wherever you use water. So what does Pani do? So you have systems, you operate systems. There are a lot of data that gets generated during the operation. Usually the data, shift-wise data, everything is recorded. And when there is a decision to be made, it takes a long time for the decision maker to go through all the data. நீங்க ரெக்கார்ட் பண்ணி வச்சிருப்பீங்க, பட் எதனால இந்த டிசிஷனை இன்னைக்கு இதை எடுக்கணும் அப்படின்றது பாத்தீங்கன்னா, it is mostly very time consuming to refer all the data from all the logbooks. So with Pani, we can pull out all the data into a centralized platform. So it is just making first data, all your logbook data into digital data. It can happen even if you have logbook entries, we can convert into digital and bring all the data into one space, so that every stakeholder, right from your operation team, your utility team, it could be a factory manager, everybody can view that data. And the data is not like this is a raw data. We can convert that data into better visuals, rather graphical. So if you ask a logbook entry of 1 year to get graphically converted, it is highly impossible for the operating team. They have to spend weeks together to outlays, remove errors. But with Pani, you can just do it in minutes. So you generate a trend and see what is happening. Actually, the data starts communicating and telling that your plant is running like this. So if at all, if I take an example of say a reverse osmosis system per se, if you see a trend where there is a constant pressure building in the feed side of the RO system, your feed pressure is increasing. That means the reverse or the membranes are not letting in water. So they are physically, there is some barrier. There could be fouling happening. And sometimes if this happens in the end membranes, you can also anticipate that there is some scaling happening. So better we take a CIP today. So the CIP call is purely driven by your data trend. So usually CIP call lies with the operator. So operator எப்ப வந்து போன மாசம் பண்ணோம் இல்ல 4 வாரத்துக்கு முன்னாடி பண்ணோம் இப்ப பண்ணலாமே அப்படின்ற கால் வந்து it is purely with the operational team, but it helps your operation team to decide. It just by monthsல இல்ல days கழிச்சு பண்ணலாம் அப்படின்ற கால் விட it becomes more systematic when the operator decides, okay, I see a trend of the feed pressure increasing. I will proceed for a CIP. It becomes a justified call. Data is justified. Why did you do a CIP? Because the performance is like this. So this is just an example. So we are making with Pani the advanced solutions also. You can map, if at all your product uses water at different stages, you can map the entire water consumption. In industry, we call it water usage ratio, WUR. So if at all your product uses water at various stages, what is the water footprint? Energy mari. So per product produce பண்றதுக்கு how much kilowatt energy அப்படின்ற மாதிரி per product produce பண்றதுக்கு how much do you use water? It can be perfectly mapped. So it is becoming a mandate, like people are disclosing WUR, my product's WUR, my water usage ratio. I will pledge, they pledge and promise that over the year I will reduce my WUR by so and so percentage. But the reduction is possible only if you monitor what is your water usage ratio. To monitor, we can build up a separate program for the entire end-to-end water that comes into your water, means your plant, till where it leaves. So that is the entire mapping that can be done, and you can monitor and see where there is gap. So where there is a gap, where you have to improve. So probably you need to improve more on your say you're losing more water on your cleaning some of your systems. So you might have to revisit the cleaning program. You can tighten it and you can extend the frequency, duration. So something like that, so that you can understand. So this is where, unless until we monitor, we don't know the gap. So Pani helps to give a real-time monitoring. First, it helps to bring all your data in one place. ஒரே இடத்துல ஒரு பிளாட்ஃபார்ம்ல வெப் லாகின்ல you can see all the plant data, and if people are operating multiple factories, this is more beneficial that you get all the factory data in one head office or one centralized location. Second, it is not the same logbook data, enormous logbook data. It helps us to convert that into easy, understandable, desirable. That means inferable. Inferable is whatever data is there in the logbook, what does it tell us? Unless until somebody infers something, you can't act, you can't decide. So it makes inferable data, and it also helps us to provide the monitoring set parameters. Like once you understood the gaps, so you go and tell, okay, the operation must be fine-tuned. I put some alarms. When this operation exceeds this parameter, I need to have a notification. I need to say my operator to slow down the system. I need to say my operator to clean the system. So like that, we can set n number of communication alerts, KPIs, procedures. So each layer by layer, we can keep adding, and it helps the operating team. Instead of being puzzled, why should I do? Should I wait for? Should I always be dependent on the high-level team to tell me why this is happening? All those puzzled decisions can be fine-tuned as data-driven decisions. So like if you have a lesser downtime, any plant, if you have a lesser downtime, or if you are not being taken away by surprise maintenance, maintenance related failures of plant, you can always optimize the operating cost of the plant. That means you are doing a more proactive So if you see some cases, if you see the trends, we understand that assets like your membranes are aging, and we might have to have a stock of membranes or stock of cartridges to be loaded by next month, so that you don't wait to the last moment. Okay, RO cartridge failed and I'm going to stop the plant and I'm going to buy and replace. It's going to take a whole week. So remaining idle for a whole week increases your operation cost. So instead of that, with the trends, you understand, okay, this is how my replacement is happening, or this is how my chemical consumption is moving. So let me plan ahead and stock my chemicals or my consumables, so there is a minimal downtime and the risk is always under your control. So when we approach the whole principle of circular economy with water as a backbone, so this is the baseline. We understand what is the impact that water can create to the entire business of yours. We understand what is water in and water out. How do you manage water at your factory? Then we recommend what is the ways and methods that you can improvise the efficiency of your water use. Like all the technologies that we have seen so far, we can recommend certain technologies in certain areas of your water process flow. So then we build upon the monitoring platform. It is not that we deliver only the technology. We also help you to monitor how this entire program is going on. That is through Pani. So we also help go beyond your boundary conditions of your industry. How you can help mitigate the entire impact of your water intake through the entire hydrology basin. If a river basin your company is situated, we also help you to restore the balance of water in your surrounding basin. That is what is restoring water to nature is. So and the moment is where you transit yourself from becoming water neutral to water positive. So ultimately we can help you in every step of this journey, right from understanding your water balance. Are we doing is my water balancing effective? Do I have to improve my water use efficiency? How, if after improvement, how do I monitor my entire water management plan? Once I am done with my industrial water balance, how do I contribute to the hydrology basin that I'm looking? That is what water stewardship is. We are moving from water management to water stewardship. Water stewardship is a collective action. Namakomoto yosikama, we are also thinking for the basin from which we are taking water. So your water, even if it's a groundwater, it is being designated into different basins, so that the groundwater is being shared by different people. It could be your industry, co-industries. It could also be some, agrarian societies, farming fields. It can be some, urban clusters where they are also sharing for drinking water. So we will be more responsible if we go from water management towards water stewardship. So we help in achieving that goals with our concept called water positivity. So like I said, with water positivity, we can help you see how your water goal is. Can we improve the water goal? If there is no scope of improvement within your industrial limits, we help you to source, or we help you to fund other water projects that are in the regional areas which can get you back water credits or verifiable water credits. That is how you move from even if you don't have a scope. Some industries say, we don't have a scope for improvement beyond this. We don't use beyond this, but still we want to be water positive. That is where we come and bridge the gap between the industries and the other stakeholders or other social stakeholders of that basin. So these are few of our partners. We have seen Electramet, Rotec, Water Positive. We have engaged with Eco Positive. And Pani is our digital platform provider, and Zwitterco helps us with superfiltration. So we are transforming the scope, the entire space of water circularity, and resource recovery when it comes to industrial waters. We deal mostly with industrial waters, starting from concept to commissioning, operational management, as well as providing, taking them from water neutrality towards water positivity. So I think we can have the floor open for a few of the questions. If the participants have, we will be happy to answer them. Ganesh, I think we can open the floor for questions if we have, Ganesh.
Yeah, yes, ma'am. So is there any questions? The forum is open to you. Participants, is there any questions?
Questions, probably we can leave Mr. Vignesh's email ID in the chat box, and you can pen down your questions if you have anything on specifically on the technologies that we have discussed. You can discuss on technologies, or in your organizations and your ecosystems, do you feel that there is a need for any of these technologies, or in common? Hello?
Hello.
Yes, sir.
Hello. Hearing me?
Yes, Anamali, sir, we can hear you. கேக்குது.
Ma'am, any possibility in future in the groundwater formulas when the local body?
புரியல சார். கிரவுண்ட் வாட்டர் என்ன பண்ணணும்னு கேக்குறீங்க?
கிரவுண்ட் வாட்டர் இப்போ நீங்க வந்து வாட்டர் மேனேஜ்மெண்ட் பத்தி சொல்லியிருக்கீங்க. இந்த
ஆமா.
கிரவுண்ட் வாட்டர் வந்து லோக்கல் பாடி இல்ல கார்பரேஷன் கவர்மெண்டா கூட வந்து எப்படி வந்து அதை ஷேர் பண்ற மெத்தட்ல எதுவும் சொல்லலைங்க.
அதாவது சார், கிரவுண்ட் வாட்டர் வந்து கவர்மெண்ட் பாடி பாத்தீங்கன்னா, உங்களோட இண்டஸ்ட்ரி எங்க இருக்கோ அந்த இண்டஸ்ட்ரி அந்த ஏரியாக்கான வாட்டர் ஸ்ட்ரெஸ்ஸை வந்து கிரவுண்ட் வாட்டரை மேப் பண்ணிருப்பாங்க சார். ஸோ உங்களோட இண்டஸ்ட்ரி வந்து கிரிட்டிக்கல் ஏரியால இருந்துச்சுன்னா, they will not allow you to withdraw more water, or they will cap your water withdrawal. ஒரு நாளைக்கு இவ்வளவுதான் அப்படின்னு கேப் பண்ணிடுவாங்க. ஒரு வாட்டர் மீட்டர், you cannot withdraw even if your land is yours, you cannot withdraw water more.
Okay.
So that case, people will have, they cannot expand the industry இல்லையா? வாட்டர் இல்லன்றதுனால அந்த இடத்துல லேண்ட் இருந்தாலும் you are constrained with expansions. That is when people look wastewater as a source. They try to take recover as much water as possible and use for auxiliary, even if it is not for the direct purpose. We have seen companies using them for auxiliary purpose. Your utility, boiler, cooling towers எல்லாத்துக்குமே recovered wastewater use பண்ணிட்டு process water alone they will withdraw from ground.
Okay. Thank you.
Team out, we had to be bilingual because we had people more regionally from this part of India. So probably I hope being bilingual was okay. After all, we wanted to understand it better. You can write to us and we can definitely clarify.
I hope no other questions. Can we move forward? Thank you so much, both of you, for that highly informative and engaging session. In today's session, we dwelled into a comprehensive range of innovation shaping the future of water management. We explored advanced water and wastewater treatment solutions. We also discussed the efficiency gains enabled by high recovery RO systems and concluded with the transformative impact of digitalizing across the water industry. Thank you, ma'am. So I request all the participants to fill the feedback form that is in this chat box. So I have a small information that IWMA is going to organize a seminar for the industry members on March 7th in Chennai. So we will be forwarding the details to you through mail. So interested participants can join. So now we are into this closing session. On behalf of IWMA, our office bearers, executive members, all participants, I extend our sincere thanks to you once again for your excellent contribution in this webinar. Thank you all the attendees for your active participation. We look forward to seeing you again in the future seminars. Have a great day ahead. Thank you.
Thank you, sir. Thank you.